Lockouts and disconnects are often discussed regarding residential electrical safety. Lockouts are devices that physically prevent equipment from being energized during maintenance or repairs. Their primary purpose is to protect workers from electrical hazards. However, in residential environments, lockouts are not commonly used. The reasoning is that most electrical work is done by qualified electricians who understand the safety hazards. Also, residential electrical systems can typically be de-energized at the main breaker panel, reducing the need for individual lockouts. Disconnects, on the other hand, allow for the electrical circuit to be disconnected from the power source. Disconnects are required when the equipment being serviced is not visible from the main breaker panel. In residential settings, disconnects are generally installed for major appliances like dishwashers and water heaters. This allows these appliances to be de-energized for maintenance or repairs without shutting off power to the entire house. The National Electrical Code, or NEC, mandates disconnects for certain electrical equipment including major appliances such as dishwashers and water heaters, electric motors, and transformers. The NEC does not specifically require lockouts, but recommends them for industrial and commercial settings where electrical hazards are more prevalent. Disconnects enhance safety by enabling the de-energization of the electrical circuit, but they may not always be practical in residential settings. For instance, placing a lock on a water heater or dishwasher could complicate routine maintenance. In conclusion, deciding whether to use lockouts and disconnects in residential settings is complicated, with no clear answer. While safety is vital, practicality and ease of use are also important factors. Disconnects generally offer sufficient protection in most homes without the inconvenience of lockouts. The decision to install disconnects depends on several factors. Firstly, the specific requirements of the National Electrical Code, or NEC. The NEC mandates disconnects for certain appliances and equipment, as previously mentioned. Secondly, local building codes may have additional requirements for disconnects. It is crucial to consult local codes to ensure compliance. Thirdly, the location of the appliance or equipment relative to the main breaker panel is important. If the appliance or equipment is not within sight of the main breaker panel, a disconnect is generally required. Fourthly, the potential hazards associated with the appliance or equipment should be considered. Appliances and equipment that pose a higher risk of electrical shock or fire may warrant a disconnect. Lastly, the accessibility of the disconnect for maintenance and repair purposes is important. The disconnect should be easily accessible to qualified personnel. There are several types of disconnects available for residential use. One is a circuit breaker disconnect, which is a circuit breaker installed in a separate enclosure near the appliance or equipment. Another is a fuse disconnect, which uses a fuse to protect the circuit and provide a means of disconnection. A switch disconnect is a simple on or off switch that disconnects the power to the appliance or equipment. A pull-out disconnect is a type of disconnect that uses a pull-out handle to disconnect the power. The selection of the appropriate disconnect depends on the specific application and local code requirements. When installing disconnects, it is crucial to follow all applicable codes and regulations. All electrical work should be performed by a qualified electrician. Proper grounding is essential to prevent electrical shock hazards. The disconnect should be readily accessible and clearly labeled. Regular inspection and maintenance of disconnects are necessary to ensure proper operation. It's important to understand the ratings and specifications of disconnects. Disconnects are rated for voltage, amperage, and horsepower. The voltage rating indicates the maximum voltage that the disconnect can safely handle. The amperage rating indicates the maximum current that the disconnect can safely carry. The horsepower rating indicates the maximum horsepower of the motor that the disconnect can control. It is essential to select a disconnect with ratings that are appropriate for the application. The NEC provides specific requirements for the sizing and installation of disconnects. NEC Section 430.109 covers disconnecting means for motors. It specifies the type and rating of disconnects required for different motor applications. NEC Section 440.14 covers disconnecting means for air conditioning and refrigeration equipment. It outlines the requirements for disconnects serving air conditioning and refrigeration units. NEC Section 422.30 covers disconnecting means for appliances. It specifies the requirements for disconnects serving various types of appliances. These sections of the NEC provide detailed guidance on the proper selection and installation of disconnects. In addition to the NEC, there are other standards and guidelines that may be relevant to the selection and installation of disconnects. AL, or Underwriters Laboratories, is a safety organization that develops standards for electrical product. UL 98 covers enclosed and dead front switches. It provides requirements for the construction and performance of disconnect switches. The National Electrical Manufacturers Association, or NEMA, is a trade association that develops standards for electrical equipment. NEMA standards provide guidance on the application and installation of electrical equipment, including disconnects. These standards and guidelines can help ensure the safe and proper installation of disconnects. There are several common mistakes to avoid when installing disconnects. One common mistake is using the wrong type of disconnect for the application. Another is failing to properly size the disconnect for the load. Improper wiring connections can also lead to problems. Neglecting to properly ground the disconnect is a serious safety hazard. Installing the disconnect in a location that is not readily accessible is another common mistake. Ignoring local code requirements can result in violations and safety issues. By avoiding these common mistakes, you can ensure the safe and proper installation of disconnects. It is also essential to understand the importance of lockout-tagout procedures. Lockout-tagout is a safety procedure used to prevent accidental energization of equipment during maintenance or repair. It involves disconnecting the power source and placing a lock and tag on the disconnect to prevent it from being turned on. Lockout-tagout procedures are essential for protecting workers from electrical hazards. OSHA, the Occupational Safety and Health Administration, has specific requirements for lockout-tagout procedures in industrial settings. While lockout-tagout is not typically required in residential settings, it is still a good practice to follow when working on electrical equipment. The basic steps of lockout-tagout include firstly identifying all sources of energy to the equipment. Secondly, notifying all affected employees of the lockout. Thirdly, disconnecting all sources of energy. Fourthly, locking out the disconnect with a padlock. Fifthly, tagging the disconnect with a warning tag. Sixthly, verifying that the equipment is energized before starting work. By following these steps, you can ensure that the equipment remains energized during maintenance or repair. In addition to safety, there are also energy efficiency considerations related to disconnects. Disconnects can help reduce energy consumption by allowing you to easily turn off power to appliances and equipment when they are not in use. This can be particularly useful for appliances that consume standby power, such as televisions and computers. By using disconnects to turn off these appliances, you can save energy and reduce your electricity bill. Timers and occupancy sensors can also be used in conjunction with disconnects to automate the process of turning off power to appliances and equipment. Timers can be programmed to turn off power at specific times of day. Occupancy sensors can detect when a room is unoccupied and turn off power automatically. These technologies can help further reduce energy consumption. Regular maintenance of disconnects is essential for ensuring their proper operation and safety. Disconnects should be inspected regularly for signs of damage or wear. Loose connections should be tightened. Corroded contacts should be cleaned or replaced. Damaged or broken parts should be replaced. The disconnect enclosure should be kept clean and free of debris. By performing regular maintenance, you can extend the life of your disconnects and ensure that they continue to operate safely. When troubleshooting disconnects, it is important to follow safe electrical practices. Always disconnect the power before working on a disconnect. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Use a multimeter to check for voltage and continuity. Follow the manufacturer's instructions for troubleshooting. If you are not comfortable troubleshooting disconnects, consult a qualified electrician. Common problems with disconnects include firstly tripped circuit breakers. Secondly, blown fuses. Thirdly, loose connections. Fourthly, corroded contacts. Fifthly, damaged parts. Sixthly, faulty wiring. By systematically checking for these problems, you can often identify the cause of the disconnect malfunction. In summary, disconnects are an important safety device in residential electrical systems. They provide a means of disconnecting power to appliances and equipment for maintenance and repair. The NEC requires disconnects for certain types of equipment. When selecting and installing disconnects, it is important to follow all applicable codes and regulations. Regular maintenance and troubleshooting are essential for ensuring their proper operation and safety. By understanding the principles of disconnects and following safe electrical practices, you can help protect yourself and your family from electrical hazards. And remember that electricity can be dangerous, and it is important to consult a qualified electrician for any electrical work that you are not comfortable performing yourself. Choosing the right type of disconnect depends on the application. For example, a water heater typically requires a non-fused disconnect switch located within sight of the appliance or capable of being locked in the open position. This allows for safe servicing of the water heater. A dishwasher, similarly, often uses a disconnect switch or a circuit breaker that can be locked out. For central air conditioning units, a weatherproof disconnect is necessary, usually located outside near the unit. This ensures that the unit can be safely de-energized during maintenance, even in wet conditions. Smaller appliances might use a simple plug-in disconnect or a readily accessible switch. The key is to select a disconnect rated for the voltage and amperage of the circuit it's protecting. Proper installation is crucial for safety and code compliance. Firstly, always turn off the power at the main breaker before working on any electrical circuit. Secondly, use properly sized wiring for the disconnect, matching the circuit's amperage. Thirdly, ensure all connections are tight and secure to prevent arcing and overheating. Fourthly, ground the disconnect properly to protect against electrical shock. Fifthly, mount the disconnect in a readily accessible location. Sixthly, label the disconnect clearly to indicate what it controls. Finally, test the disconnect after installation to ensure it functions correctly. Remember, if you're not comfortable working with electricity, hire a qualified electrician. Maintaining electrical disconnects involves regular checks. Firstly, inspect the disconnect for any signs of damage, such as cracks or corrosion. Secondly, test the operation of the disconnect to ensure it switches on and off smoothly. Thirdly, tighten any loose connections. Fourthly, clean any dirt or debris from the disconnect. Fifthly, check the wiring for any signs of wear or damage. Sixthly, replace any damaged components promptly. Regular maintenance can prevent many electrical problems. Electrical safety is paramount. Always treat electricity with respect. Firstly, never work on electrical circuits when they are energized. Secondly, use insulated tools and wear appropriate personal protective equipment. Thirdly, be aware of your surroundings and avoid contact with grounded surfaces. Fourthly, never overload electrical circuits. Fifthly, keep electrical equipment dry. Sixthly, if you're unsure about something, ask a qualified electrician. Remember, electricity can be dangerous, but by following safe practices, you can minimize the risk of accident. Understanding the codes and standards that govern electrical disconnects is essential for ensuring safety and compliance. The National Electrical Code, or NEC, is the primary standard for electrical installations in the United States. It provides detailed requirements for the selection, installation, and maintenance of electrical equipment, including disconnects. Other relevant standards include UL standards for safety testing and NEMA standards for electrical equipment manufacturing. Local building codes may also have additional requirements. Consulting with a qualified electrician can help you understand and comply with all applicable codes and standards. Disconnects play a critical role in ensuring electrical safety in residential settings. By providing a means to safely de-energize electrical circuits, they protect against electrical shock and prevent accidents during maintenance and repair. While lockouts may not be practical in all residential situations, disconnects are an essential safety feature that should be properly installed and maintained. By following safe electrical practices and complying with all applicable codes and standards, you can help create a safe electrical environment in your home. If unsure, always reach out to a qualified electrician for assistance.